Okay, hello again. So one little correction I have to do for the stretch, okay? Like last minute that I did. If I take lines, the original line and a transform line, and I intersect them, I extend them, they don't always necessarily extend on the origin, but they must extend on the invariant line. In this case, it was the x. Okay, so it could be on the origin, but it could be a little bit to the left or a bit to the right, but it has to be somewhere on the invariant line. Okay, cool. Moving on to shear. I'll pause here. Right, so shear, I'll be honest with you, is a bit more tricky, and this is maybe one transformation that it's worth remembering, perhaps. Okay, but this is shear. Okay, if you take, it works well with a deck of cards. I forgot to get the deck of cards, but anyway, imagine that you go like this. Okay, so imagine a deck of cards, and you squash it to the side, it spreads, okay? But there's still one little difference is that the further away you are, it will stretch even more, okay? So I'm gonna just show you our normal box, okay? Let's say we have a little box that I made out of our unit vector, okay? If I'm doing a shear in the x direction, it would look like this. We'll do blue, okay? This vector will go onto here. This vector will go onto there. Okay? All right? Now, where exactly? Sorry, no. Yeah, sorry. Sorry. Okay? There's only two vectors here, so there's no three. This vector is going to go there, and this vector actually stays the same. Okay, if I had another vector here, yes, he will stretch it in the direction I showed you. Okay, okay, so I'll draw that if you know, if we want. So if we have this whole shape, that is going to go to here and that's going to go to there. But if I'm just looking at the unit vector, this vector is going to go to there, this vector remains the same. If I have another line, it will stretch in this direction. Okay, so it's like a deck of cards. All right, now let's do the usual thing. Okay, so 1, 0 will be transformed to, it's only on you now, Olivia.
Oh gosh, it's the same.
It's the same, he doesn't get transformed. Okay, and then the 0, 1 is transformed, right?
45 degrees.
Well, I just drew it, I could draw it at a smaller angle. Okay, don't hang up on 45, it could have drew something here. So, but let's think about it. Let's start with the y. What will be the y value as long as it will be the same? It's the x that changes, right? So let's say it's stretched, it goes to k. Okay? So what we've got here is a shear in the x direction. A box like that becomes a parallelogram like this. Okay? The direction of the shear is in the x direction. But what is the invariant line? Which one doesn't change? The x doesn't change. So that's the difference between a shear and a stretch. In a stretch, if the direction is in the y direction, the x is the invariant line. Okay? If the direction of the stretch is in the x direction, it's the y that doesn't change. In the shear, if it's shearing in the x direction, it's the same direction that doesn't change. The same invariant line that doesn't change. The x. Okay? So, I know it's confusing. So shear scale factor k, where the invariant line is x, will simply be 1, 0, k, 1. Okay? A bit confusing. We will do example at the end. Let's just do the y and then we'll do an example. Okay, now we're going to do a shear in the y direction. So a shear in the y, if a shear in the x direction is like this, a shear in the y direction is like that. Okay, from the black square into this blue parallelogram, and we want to build the parallelogram. Okay, or we want to build the matrix. So let's see. Now we need to ignore these two lines. We just need to look at our friends, the unit vector 1, 0 and 0, 1. Just at these two vectors. Don't look at those lines. Okay. Now in this case, which one changes? The 1, 0? It's the 1, 0. It's the x that changes. Okay? The 1, 0 will become, I'll do it in blue. It becomes, the 1 is still a 1, the x is still a 1, but now the k is not 0, it's a k. I mean, the y is not 0, the y now is k. So 1, 0 becomes 1, k. Where the 0, 1 remains 0, 1. It doesn't change. Okay? And therefore, let me just pause here. Okay, so now we have a shear scale factor k, invariant line now. What did I write here? Invariant line is the y-axis. Okay? In this case, it's going to be 1, k, 0, 1. Okay? Great. Now we're just going to do a little example. Okay, how am I going to pause it? Okay, so what I'd like to do, I've got this shape, we just made it up. Okay, it's 1, okay, or 1, 0 really, 0, 1, and 2, 2. And we want to see, what shall we do? Shear x direction or y direction? Y. Okay, we did the x before, now we'll do y. Okay, so what we're going to do, we're going to put our scale, the shear in the y direction is 1, 0. Shall we use k2 this time? Make it a bit simple, okay? And we're going to multiply it by each one of the coordinates. So we'll start with 0, 1. Okay? 1, 0 times 0, 1 is?
Oh.
Yeah. You're the only one. Yeah. See if it doesn't
Oh,
come.
guys, I'm so sweet. What?
1, you see, like a doop, doop. Okay, it's 1 times 0 plus 0 times 1. A bit late. I'll help you. 0. Okay? Okay? 2, 1 times 0, 1 is 1. We could have known that already, Olivia, because you know we know that when we're shearing in the y direction is the y invariant line, or stays the same. So that stays in the same spot. So I'll put a red dot on it so we know that stays there. Okay. Now let's do 1, 0, 2, 1 times 1, 0. Okay? I'll just pause. You're looking. Okay, so just in case you're getting confused, guys, those 1s and 0, 0, 1s, this is, I know it is our unit vector, but now we're just looking. The question is, what will happen to this shape? I could have easily, and in the exam I will, I can tell you, I'm going to draw a square here, which is, let's say, 3, 1, 3, 2, no, that can't be 3, 4, 2, 4, 3, and 3, 3. And I'm going to ask you, what is that going to be transformed? You understand? Then you just need to put these coordinates here. So the shape doesn't have to be on the origin. In fact, most of the time it won't. Okay? Right. But let's carry on with this. All right. So 1, 0 times 1, 0 is 1. 2, 1 times 1, 0 is going to be 1, 2. So the new, which one? The 1, 0 is going to be 1, 2. So it will be 1, 2. So he's going to jump up to there. This one stays the same. This one stays there. Okay? Now, next one. Let's have a look. So we've done 2 points. We've done that one is that one. What other points do we have?
The 2 bottom one.
2. Well, I've done that one. That was 1, 0 became 2, 2. Yeah. 0, 1 remain the same. So I've got 2 more points. I've done that one. I've done that one.
You've got the other 2.
This one and?
And the origin.
And the origin. Let's do the origin. 1, 0, 2, 1. What should happen to the origin? I think we can guess. Because is it on the y-axis?
Yeah.
So it's invariant. It has to be the same. And that actually will be for either kind of shear. Because it's also on the x-axis and the y-axis. So whenever I have 0, 0, it's going to remain 0. So this one stays the same. Last one, guys. Oh, before the folder comes in, we got to be quick. Okay, we've got 2, 2, right? 1, 0, 2, 1. I'm going to multiply by 2, 2. Okay? 1, 0 times 2, 2 will be 2. 2, 1 times 2, 2 is, that's going to be a bit confusing. 2 times 2 is 4 plus 2 is 6. So look at this. Okay? This is going to jump to 2, 6. 2, 3, 4, 5, 6. Let's say somewhere here. So the new shape is going to look like that. Okay? Right, so we've got shear in the y direction. And as I told you in the beginning, it's not like a deck of cards. I know it's a bit like a deck of cards, but the further away you up, the further up you are, the more of a shear there is. Okay? This moves up more than this, just like in the stretch. Okay? Right, I think we're going to end up here, otherwise we're all going to go crazy. What are we going to do in the next lesson? Next week, it will be a short one. We'll do combination of transformation. So rotation and the reflection. Okay? It's not as hard as it sounds. Cheerio.